guess the REM song I've been listening to, given the day. How the West Was Won. Here we go. Yeah, here we go. Someone's got it. Right. So yeah, this is really potted history of what we've been up to in playing around with AI and a few thoughts as to where we as an organisation might be going next. I'm David. Work at the IET, one of the world's largest engineering institutions, 168,000 members in 150 countries. We've been going for over 150 years. Seems like all of those 150 years have been this year, because as I said earlier on, we've been restructuring, and that's been quite an epic thing to be going through. And our mission is to engineer a better world by inspiring, informing and influencing our members, engineers and technicians, and all those who are touched by or touch the work of engineers. So I'm going to go through just a bunch of stuff that we've been dealing with in terms of trying to wrap our heads, a bit like the Emerald team, in terms of trying to wrap our head around the impact of AI on us as an organisation. Thought I'd start here. Not going to spend too much time on this. Sven did a great talk, I thought, bringing some of this stuff up. But if you think about it as an input problem in the stuff that we have to deal with and the stuff we have to turn into something material and something useful, this is not the slide where we laugh at other people's misfortunes. This is the slide where we go there, but for the grace of God, go we all. Yeah, lots of people having lots of trouble. I just really wanted to bring this up because I was quite shocked to hear my scholarly publishing colleagues in the journal side talk about what their experience was last year. We were going to launch some journals, some new journals. We had to stop that because the tide hit us. And we had to stop a deal with that, and we literally couldn't spare the person power in order to launch those new journals. And without going into too many details, this was the stuff when not only were we in engineering, computing, and the rest of it being hit by misinformation, fraudulent papers, those kinds of things, but we were being hit by stuff that had a high amount of AI-generated material in it, and it turned out to be really, really hard to get on top of that. This is a number, I'm going to say it, don't quote it as official. I believe we had 1,300 papers. We're not a particularly large publishing operation in the overall scheme of things, but we had 1,300 papers that were so problematic that we couldn't do anything with them, and that obviously caused all kinds of issues. The guys, when they were trying to get to grips with it, were doing a bit of work where they were trying to understand what happens if you get stuff out of ChatGPT, and this is just a sort of illustrative thing. So they asked GPT-4 to come up with some references with DOIs, and this is the results. I don't know if you can see that up there, but basically none of them are correct. Okay, that's annoying, but that's not too bad. The real problem actually is 4 of them have a correct DOI in that it resolves, right? It's just that it doesn't actually resolve to the right paper, right? And that's a deceptively tricky problem to try and solve. And Sven was talking, and others will be talking about it. So this is a personal opinion. I'm going to try and restrict the rants as best I possibly can up here, the time I've got with you. But it was telling. Sven had the picture, the Nature paper, about the publishers ranked by the amount of disinformation they were dealing with, right? And I sat there, and it's fascinating, isn't it? Went straight to the publishers. Right? Where are the research institutions? Nobody's ranking the research institutions by the amount of misinformation and disinformation they're outputting, are they? No. I had a conversation with the journalist who produced that, actually. He's going to try and come up with that data and produce something there, because that's where it's coming from. Okay? What about the funders? More on the funders in this talk in a minute, right? But we're dealing with the input problem, right? And we shouldn't be dealing with that input problem by ourselves, notwithstanding the good ideas that are going on there. Right, let's move to the output problem, AI versus the wiring regulations. So this is what you do when you discover that the AIs have casually cloned one of your key pieces of intellectual property. And whereas previously, you know, I'd have blamed the people for the work that we're having to deal with on the input side, I'm totally blaming the tool for this one. Okay, so a bit of a background. The IET wiring regulation, 7671, it's the BSI standard. Yay, thank you very much. Very good engineer over there in the corner. Lovely job. We've been doing these for about, I think, over 100 years now, and there are regulations. They're really, really important. Everything in this country that has an electrical power supply of some sort, whether it's a building or whatever, has to comply to the wiring regulations. And the reason for that is very, very simple. It's important that you don't die when you turn on the power. It's literally that basic and that simple. So we have this standard. It's put together very carefully. If anybody want to ask me the question while we talk about the fact that it has 620 pages, come find me over lunch. I'll tell you a little story about why that is the case. But we have a committee, right, of learned, very senior, very important experts who spend a lot of time and energy delving into the really detailed minutiae of how to do proper power installations and all the aspects thereof. It's absolutely incredible stuff. God bless them. It all happens in Word. Been trying. We're trying again this next time, but still happening in Word. But as soon as we get the stuff in, we turn it into XML and we do properly good stuff with it. We use something called R Suite to do that. But anyway, we do have to be careful. We have to put the stuff out. There has to be a public consultation on it, so we have to be careful about that. That's a little bit less secure. That's important. We have had stuff where things have accidentally leaked a little bit during the committee phase, again, by accident rather than intention. But we do have a real problem with printed count. Electricians love a print copy. Okay, we tried to turn them electric, right? They didn't really like that. Weird, but anyway, they do like a paper copy. I think it's because you could keep a fire door open with a copy of the wiring regulations. Indeed, yeah. Yeah, so anyway, we have holograms, we have all kinds of stuff. Again, lunchtime, I'll tell you some stories about that. So personal story, I've been trying to decarbonise my lifestyle. One of the things I've been doing is trying to decarbonise my house, which means getting it off the oil supply. That's how I do heating and all the rest of those kinds of things, and go to electrification. If you do that, one of the things you have to understand is a thing called maximum demand, which is how much power your house might take, and bluntly whether the fuse board can handle it. So I started having a poke around at that, and I'm looking at the results that are coming back, and I'm playing around with ChatGPT, and I'm like, some of these replies have got some language that seems just a little bit familiar to me. So I went and asked, this is the sequence, but I started to have a poke around, and as I start to ask more and more questions, it becomes apparent that there's something really, really going on. So those were the 5 questions that we've got there, and at the end of it, I'm sitting there going, damn it, they've got the wiring regs, which is a really big deal. Okay, the wiring regs are not out there freely available, right? You have to buy them, you have to pay for them. It's really important. You can't just hoover this stuff up with a robot coming to a website, okay? So we did a lot more work. We looked at GPT 3.5 and 4, Mistral, Llama 2B, we looked at those locally, more on that in a minute. Phi 3, I think we could still say that's the new one from Microsoft, and Claude. And we asked them the same set of questions. All of them had specific details about things in the wiring regs. Specific details that you can only get by accessing the wiring regs. Okay? They had tables, they knew where they were, all of those kinds of things. Mistral and Llama 2B, which we're running locally, more on that in a minute, got details wrong. Don't think they were hallucinating. Think it was probably a source problem, right? We think that those have been built on a model that had got some version of a pirated copy with mistakes in it and all the rest of it because of the way they did the replies. Phi 3, that was really interesting. I don't know if any of you played with Phi 3, it's one of the models from Microsoft. Don't want to anthropomorphize it, but it was cagey. I got the sense fairly early on in questioning it that it knew it was being asked to provide answers about something for which the copyright status might be, shall we say, a little bit in the air, and it did not want to give me specific answers, no matter how hard I tried. Clearly knew about the wiring regs, but it was very, very careful indeed about the sort of reply that it actually gets. that we actually got. Then we get to ChatGPT. So take a picture if you want. GPT 3.5 on the left, GPT 4 on the right. This is one of them. Explain to me what the IET's wiring regulations say about calculating max demand in a residential property. It's a very specific question. You can immediately see, without reading the text, I think, the changing complexity and detail of information on the right-hand side versus the left-hand side. That's a nailed-on set of results from our wiring regs, lightly rewritten, okay? Again, can you provide details on table A1, which is a very specific table to do with max demand? And as you could tell, 3.5 was like, no, I can't do that. I don't have access to it. Couldn't get around that. GPT-4 did a little bit of prompt engineering, asked it to pretend that it did actually have access to it, and what if it did have access to it, what might it find in that table, and it came up with a text version of the information that's in that table, and it's perfect. Yeah, so rant number 2. They always go on about fair use. Our new government, apparently I was reading in The Guardian just over the weekend, is considering the idea that we all might, as content creators and content regulators, have to opt out of letting the AI just go and harvest all of our material. I'm like, really? Because these are wiring regulations. These stop people from being killed, right? It's really important that they're right. It's really important that everybody that could be confident that all the stuff that comes from a regulation, whatever it might be, right, could be satisfied that what they're getting is right, because people's lives actually really hang on this stuff. And I've got another example for you in a minute. Also, by the way, we're not covered by fair use in the UK. Cough, burn the convention, cough. All right, shut up, move on now. Right, how am I doing? Right, okay. InSpec, for those of you that don't know, never had to sit through one of my other talks about how wonderful InSpec is. It's an abstracting and indexing database, contains physics, computing, all sorts of other bits and pieces. About 28 million academic research papers have been abstracted. About 8-9 years ago, we did the old AI, the good old-fashioned machine learning stuff with InSpec. And we've been very happy with the stuff that we've done there. What we were trying to do here was to see if there was anything useful in applying these new language models to the customer side output of what you can get from InSpec. So here's just a few examples. We'll see what they actually look like on screen. Here's the first one. What was the most common subject of the second quarter of 2023? Now, we actually had a lot of difficulty doing this. We did this locally, more on that in a minute, and we were just providing abstracts, pointing the large language model, or the large language model, at these abstracts and asking it to do something with it, and it was doing a terrible job, right? I didn't really know what it was doing, but it was absolutely all over the place. Now, this uses something called LangChain, which is a development framework you could use if you're playing with a large language model locally, or actually in the cloud as it happens. We found a thing that allowed us to go back to good old SQL. So because InSpec at its heart is a lovely SQL database, don't knock it, people, it works. We basically pointed the large language model at a SQL interpreter and asked the question, can we do funky SQL queries using a large language model to answer human-derived questions? These are some of the outputs. So what's the most common subject? The interesting thing, and again, I don't know if you can read that, take some photos if you want. The way the thing works is it translates the machine's thinking into human-readable SQL thinking. So it's a very neat way of finding out whether the machine is going right or going wrong in the way it's constructing its SQL query, which we found kind of interesting and really quite useful. So we pull this stuff up. It starts to do some thinking. It's explaining to us what's going on. Ends up going, yep, I'm happy, I'm knowing what I'm doing. There you go. There's some good old-fashioned SQL. And then we get the answer that it's happy, I'm going to run it, and then we get the answer, and the most common subject in the second quarter of 2023 was engineering materials, one of our controlled terms, with 32,586 articles, which happened to be true in the data set we were letting the machine play with. So we thought, that's interesting. Let's do a better question. Give me a summary of the articles concerning artificial intelligence released in September 2023, just a month. So I'm just going to flick through this. It's the same thing again, right? It's having a think. It did some interesting stuff about expanding the term artificial intelligence that we thought was quite neat. So it didn't just use those two words. It understood from the table structure that we given of the database that it could go and look in other places. So it did some interesting stuff there, pulled some things back. But what it thought was, you want me to summarize each result I get back. So there's a headline there, and there's a very, very one-line summary of that particular piece of research, which wasn't what we wanted. What we wanted it to do was to go and get all of the abstracts in that particular area and effectively do a sort of mini review, if you like, sort of keep you up to speed of everything that's been going on. That was in our heads. So we went and did the same thing. We changed it slightly, summarise all the abstracts, because it turns out that playing with the prompt is the thing that you've got to do here in order to do this. Go through the same thing, get a load of results back. Now we've got the stuff that it wants to play with, putting the query together, and then the final answer at the bottom, it actually does give you a summary of what the abstracts that it's found are actually saying. That's a neat parlor trick, right? The question, though, is actually how useful is it really, right? Because you start to think about time, you start to think about the cost and the effort of scaling up these kinds of queries. You start to think what happens if a load of people come in to our inspec product and start putting these kinds of queries in. There's certainly a load of cost attached to that, and you start to think about what that might mean. But the other thing, frankly, was, could we sit there and get more money? The conclusion we've come to so far is no. It's neat, right? But I'm not sure that this actually increases the value of the product sufficiently, right, to do something. It's just a slightly different search box, right? At the end of the day. I'll go through the next one very quickly to save a bit of time here. Been doing some more DIY things. And so I want to talk about the local box that we actually built. So early 2023, it's ancient history in AI terms, and my enterprise architect, a couple of our developers came to me and told me that they'd secured a really sweet deal on an NVIDIA A6000 class card. Would I let them buy it so they could kick the tires? And motivated as I was by a bonusable objective to do something useful in AI, I said yes. So we put together a machine. You won't be surprised to know that the card is hilariously the most expensive bit of that box, and we didn't spare anything else that was in there anyway. Funny story, I looked up the price Sunday night. I can actually sell that box back and I can make a profit. We've been using it. So there we go. And actually, for a while, it seemed like it was a bad idea, right? Because all the stuff's happening in the cloud, and it was getting increasingly easier to fire these stuff up and just go and throw them. The prices weren't too bad, depending on the scale at which you're operating. But then an interesting thing happened, which was we were working with a company called Softcat, who do a lot of our technology supply for us, and they were telling us stories of people that done M365 Copilot implementations. And what they discovered was they were dealing with a whole lot of how did they find out about that PowerPoint? How did they find out about my salary? How did they find out about that really ill-judged email that I fired off to a colleague in a moment of pique? And it turns out that the co-pilots are just really, really, really good at going and finding all of the useful information. And of course, you know, who amongst us has sorted out our Active Directory permission structure? There we go, people in technology. Who's sorted out the network storage and all the files and all the folders and who can access that kind of stuff? And of course, then there's the great training course of Outlook as a document store for all of your information, right? Because the AIs will go and find it. It's a small amount of upfront work to successfully deploy Copilot across the enterprise. It's only going to take you 18 months, 2 years. Or Or you can go to your local LLM machine that your technology folks have carefully put together when they were thinking about what they might do, and actually run models locally. And you can run a lot of interesting stuff on a machine like this, right? Not everything has to be enterprise class. So we've done a few things there. We took 7,000 responses. We do a member questionnaire, and one of the great questions that we put in our questionnaire is a free text box. Tell us what you think. Right, so we get 7,000 responses that are just engineers writing paragraphs. Right, and it's always been really, really tricky to analyse that stuff historically. We did that with Mistral. One of our guys sat down with the person doing the questionnaire, pulled the text out, did a small bit of text-based manipulation so we could feed it into the large language model, and then we just asked questions of the large language model, right? And so we were able to do some really, really neat textual analysis on sentiment, all kinds of sort of outlier responses, so we managed to find out who the idiots were who replied to us, so we could safely ignore those responses, those kinds of things. But we had some fascinating stuff. Took about 3 days. Previous time taken well over a month, and we had better answers this time, both in quality and an amount of information that we were able to pull back out of that. And then, if you could see this, oh look, it's the wiring regs. So from the department, if you can't beat them, maybe you should join them. We've actually got GPT-4 doing wiring regs exams. Using the proper data, but this time it's controlled so it can't leak back to OpenAI. And it turns out that it's really good at passing electrical examination tests. Very, very, very good indeed. And we are currently looking at what other sorts of things it can help with in regards to that area. Because the one thing about discovering that the AI had grabbed our stuff was that it had actually done something that caught our attention, to the extent that when we started to have a conversation with electrical engineering experts about what we were seeing, they were like, that's interesting. Right, which is always a moment when you sit there and think that maybe we should pull on that thread and see where it goes, and who knows where it will go. Right, let's change the subject. Sorry, rules and regs. One of the other things we do as a charity is we try and do policy work to help influence change. We do it in all sorts of areas, and I want to pull out some things that we've been involved with as a charity in those areas. So, this catchy number is the application of artificial intelligence in functional safety. Functional safety is not a buzzword. It's another standard, IEC 61508 from the International Electrotechnical Commission. I didn't get a whoop for that. Oh, never mind. Read about it in Wikipedia. It's actually really, really important. These are the systems that control other systems and make sure that those systems do not go wrong, right? These safety systems basically should not fail, but if God forbid they do, it's vital that they fail in a predictable and, more importantly, a safe way. It's a really, really important standard that most of you have never heard of, and it's vital for the safe functioning of the planet. Okay, so we worked with the Defence Science and Technology Laboratory to produce some guidance. And again, how does that work? Well, we put a technical committee together. We get a load of experts from all sorts of interesting places. Nuclear Regulation Inspector sort of tells you the kinds of areas that we're going with here. And they put that paper, that report together. And actually, what they do is they look at the safety life cycle model, which is what that IEC standard is all about. That's over on the left. And they had a whole report that basically says, when AI is coming your way, these are the places, these are the areas inside that framework that you need to be paying attention to in how to handle it. So this is a very practical application of trying to bring regulation and guidance around how to handle what is coming towards us in a safe and reliable manner. Because the watchword here has got to be the stuff on the right absolutely cannot mess up what's going on with the framework on the left. And of course, All that important work has been turned into a PDF. Yay. Has been downloaded it's over 1,000 times, which for an esoteric bit of writing is not actually bad, but even so, the technologist in me did die a little when I realised it was just a PDF. Maybe we could do something about that. Working with Ofgem, they're the energy regulator for Great Britain. We're involved in the Ofgem AI and Sustainability Task Force. Again, we're actually also working on a report on AI and sustainability. You'll hear the numbers about, the amount of water that gets used by data centres and the amount of CO2. It's worth actually putting that in a little bit of perspective. So I did a little bit of work on that, right? So a data centre uses about 26 million litres of water per year, something like that. Sounds quite impressive. Till you realise that the steel industry uses 73 billion litres of water in the UK. Okay, so the UK steel industry is equivalent to about 2,800 data centres. Okay, it's about 5,000 data centres around the whole world. So there you go, just a food for thought there. And here's the one I'm really interested in and really excited in. How am I doing? Got a bit of time. Okay. We had an email come in from Sense About Science. They were trying to do something with welcome, responsible handover of AI. And someone had said, you should talk to some engineers. Yes. So they came to us, and the people that they came to went, I don't really know anything about AI. Dave, go talk to Dave. So I got this slightly weird email going, hi, we're Sense About Science. Can we talk to you about AI? I'm like, not really sure we can do anything. But we had a conversation, and this got really interesting really quickly, because this is the moment where a funder, in this case Wellcome, had suddenly realised that all the stuff they've been doing, nobody's here from Wellcome, right? Good. Bless them. They suddenly realised that all the stuff they'd not been really paying any attention to in terms of the sustainability of the code that is produced by the funds that they give out might actually be a bit of a problem, right? Not just artificial intelligence, not just large language models or other things, but actually the good old-fashioned basics of what damage can code do if it's not looked after properly. One of the moments I've had this year, and there's been a few interesting ones, but one of the moments I had this year was having someone go, yeah, we need to pay attention to how we sustain this stuff instead of just handing it over and letting it do whatever it is that it goes and does. That's one of the things that we've been working on. Again, there is a really neat framework that's been put together. It was only launched last month. Grab this, go look on YouTube. There's some really, really good videos about this. We've got tool proposers, we've got tool users on the other side, and there's basically a framework. You could think, if anybody remembers evidence-based medicine, there we go, some heads nodding. This is like evidence-based medicine for computer science, okay? Trying to do proper traceability of where we got our data from, what we've done with the code, how we look at it. Do take pictures, do grab the URL and go and look it up, because it's all in there. This is the other side of it, right? Carrying on, it's really quite detailed. This has really, really landed, and it's really, really landed in a way that I just didn't imagine at the start of the year. But here's the thing, right? It's a lovely PDF. It really is a lovely PDF. It's a nice website. But actually what we really need is a toolkit to really help this live and become something that can really be adopted. All I can say about that, fingers crossed, hopefully, watch this space. That's what we've been up to. Thank you very much. Got a couple of minutes. Questions? Anybody? Go on.
There seem to be a few questions. Is that shirt AI generated, and who's hallucinating, me or the AI?
Thank you very much. Anybody else? Just don't let him get the microphone again.
Thanks for that. Some really interesting stuff there. Have you got a view of where kind of these different AI bots got access to all of your content? And then a follow-up to that, we recently blocked ChatGPT and saw a massive increase in referral traffic, which then made us question, kind of, do we want to be blocking this or not? So kind of, A, where do you think it got access to it? And B, pros and cons.
Yeah, so I don't know absolutely. There is a thing called the pile, which is a pirate repo. It's probably the pirate repo of non-fiction and fiction book literature, right? The reason we know that the large language models have been trained on that, and we absolutely do, is because they wrote about it in a research paper that you can go and read on Archive. By the way, that's a participation thing. You can't just show up and use the pile. You have to put stuff in order to be able to get stuff out. So I shall just leave that little copyright illegality confession just hanging in the air there for a moment. But I think that's where they got that from. You cannot get it's very hard to get hold of a copy of the wiring regs digitally. So loads of people pirating it and doing print versions because they buy a version and they go to work on that. But I think in the case of this, from what I've seen of the quality of the results, they got access to the electronic material. I guess somebody got it and uploaded it to the pile at some point in time, and that's where it's come from. That would be my guess on that. On the robots harvesting, obviously if it's open access, it's open access, right? That's what it's there for. That's what it actually means. I think we should all think about that, but that boat has sailed. We have a mixture of stuff. So we have stuff that actually we want as many people or things to see as we possibly can, but we also have intellectual property that we have to protect. And I personally think they ought to be a lot more careful about asking for permission. I think that's a really, really fundamental thing here. And the other problem about this is the argument falls down, right? If you ask an expert, you pay an expert who understands the wiring regs, has been certified, right, has passed all kinds of tests. They paid, right? They paid to support the entire enterprise, right? It's a self-sustaining thing. That's why you could be satisfied that someone comes in and says, effectively, someone will have warranted this building, right? The electrical design of this building will have been warranted not to kill people who are in it, right? It's a fundamental point, right? If you disintermediate that, right, by just ripping it out and have somebody perhaps not even knowing because some service has been built on top of this material, right, what does that mean for us? So I think the current conversation as I've seen about copyright and all the rest of it, I think is naive and frankly disingenuous. And I think every organisation's probably got to sit down, like we have, candidly, and have a serious think about what we do and under what circumstances the materials that we are responsible for are allowed out into these systems. But it's coming anyway, right? Sorry, long answer. Anybody else?
Really fascinating presentation, thank you. I wanted to dig a little bit into your actual experiences of running these applications, because it felt like you were running LLMs locally, LLM Studio or something like that, and LangChain and so on. Yeah. Given the stochastic nature of their output, unlike, say, traditional AI and ML, would you put in place additional guardrails, safeguards for model drift and data drift that we tend to do in the AI ML space?
Yeah, so we sort of had a fairly simple thing. Did it give a sensible looking output? Right, I mean, I would say we're still in the kick in the tire stage. We had a lot of things where we couldn't get it to do anything sensible at all. We had a naive idea that we'd be able to feed it our HR documentation and sort of have a chat bot that people could go and go, what's the HR documentation? Tell me about this stuff. And it made an absolute horrific mess of it. It was awful. And we just were like, that. We're not even going to bother trying to fix that. We don't even know what's going wrong. So we basically went, if this is giving us a result that looks interesting and good and reliable, we will pull that thread and see where it goes. That's where we discovered that Mistral, Llama 2B was not very good at all, but Mistral turned out to be remarkably good at analysing text within the very precise confines of the material that we were giving it. So it's very tightly constrained. Look at this, don't look at anything else. don't tell us anything else about it. So from that point of view, we had a mixture of results, some good and some bad. The thing we have seen in its very early days is if you're doing something like the one I showed you with the wiring regs, so long as you tell it only to use that specific data, you're actually taking advantage of its language and thinking skills in order to get answers back. And it seems so far to be quite reliable. The experts that have looked at the wiring reg stuff have said the problem's actually superficiality, right? It doesn't quite give the detail that they would like it to give. But then it's early days and there's probably plenty more work that we could do in that area. Does that help? Yeah, cool. I know I'm running long and stopping other people from talking up here, so thank you very much. Grab me a lunchtime. Cheers. Thank you.